Hello everyone, I'm Mr. Amoyavi, one of your grade 12 advanced maths teachers. In our last lesson, we talked about the product, quotient, chain rules of differentiation. Right, in today's lesson, we'll talk about how to find the derivatives of three basic trigonometric functions that we have learned. Right, so what are the three basic trigonometric functions that we have learned? They are y equals sine x, y equals cos x, y equals tan x. Right, what we will do now in this lesson is to already put down the standard results that we can use to differentiate a given trig function. So if y is equal to sine x, then the derivative of this function dy over dx will be equal to cos x. Okay, take note, if you are given a function y equals sine x, then its derivative is cos x. Right, the derivative of cos x will be negative sine x. The derivative of tan x will be, again, dy over dx will be equal to sec squared x. Sec, you know, it's the inverse of cos. So this will be the results these are the standard results that we are going to use to apply to differentiate a trig function. Right, so let's take a look at some examples. 1. Y is equal to sine 3x. Right, how do we differentiate this function here? Okay, one thing I'd like you to take note is you are going to apply, because you are going to apply chain rule here, because here we see that we have a function contained in a sine function. Right, so in order to differentiate this, we will let u equals 3x. Now, if you substitute u for 3x, then the function here becomes y equals sine of x. Rather, sine of u. All right, as you can see from this result here, the derivative of y equals sine x is cos x. Right, so by applying the chain rule, I will say the derivative of this function here will be equal to, again, if you can recall the chain rule from our previous lesson, it will be dy over du multiplied by du over dx. Right, so substituting in this formula here, firstly we have to find the derivative of this function. Y equals sine u will be cos u multiplied by the derivative of this function u equals 3x, it will be 3. Right, so we will have 3 multiplied by cos u, 3 cos u, but actually u is this part here, 3x, that we substituted. So we will have 3 cos 3x. Right, so what we have done is we have differentiated or find the derivative of this function to be 3x, 3 cos 3x. Right, the second example, let's take a look at the second example applying y equals cos x. If I have this function y is equal to, let's say, cos 2x plus 1. Okay, if I look at this question here, I also have a function that is contained in a cosine function. All right, so what I have to do is I have to do the substitution, u substitution. That is, let u is equal to 2x plus 1, and rewrite this whole function in terms of u. So it will be y equals cos u. So the next part, because it's a function that contains another function or function of a function, we will apply the chain rule again. Dy over dx is equal to the derivative of this function, y equals cos u. As you can see, cos x is equal to dy over dx is equal to minus sine. So Here I will have minus sine u multiplied by, again we are applying this rule here, the chain rule. The derivative of this function is 2. Right? So 2 multiplied by negative 1 is minus 2 sine u, but u is actually 2x plus 1, so we substitute again. So our final answer now will be 2 sine, or minus 2 sine 2x plus 1. Therefore, that is our derivative, or the derived function for this one. All right, so that is, the function is a cosine function here. So that is the second example. Now let's take a look at a third example. Number 3. If my function is equal to x squared multiplied by, let's say, 10x. Okay, see 10x, it doesn't contain another function, but we see that it's a product of two functions, x squared multiplied by 10x. So we can, as you can recall from our previous knowledge, the product rule, we can apply the product rule here. And the product rule is, if you can restate this, it will be equal to v multiplied by du over dx plus u multiplied by dv over dx. Right, so v is the second function here, so we can say 10x multiplied by the derivative of this one, this function here, x squared will become 2x, plus u is x squared, right? And v is 10x, but if you are going to take the derivative of 10x, using the standard result here, it will be sec squared x, right? So if you have to simplify this, it will be 2x times 10x will be 2x 10x plus x squared sec squared x. Therefore, the derivative of this function here, dy over dx, is equal to this function, right? So what we have learned to calculate, or learned in this, is to find the derivative or the derived function in trigonometric functions, right? So what we have learned is we apply the standard results here, or we use the standard results to apply that to find the derivative of a given trig functions, like the 3 examples that we have. So given a product, given a quotient, or given a function that contains another function, we can use the process or the knowledge that we have gained from the previous lesson to find the derivative or the gradient functions. All right, so that brings us to the end of our lesson. In our next lesson, we'll talk about the derivatives of exponential and logarithmic functions. Thank you.